How are you? Have you been discussing? Okay, I think the network issue since last night has been on my case also. Now, today we have to discuss something new, but before I go for something new, I would like to know whether we have some challenges of logarithms that you came across. Among the numbers I gave you and the assignments I told you to go and check out, are there some numbers that challenged you? And remember, I said if there is no challenge, there are two things. You either passed all the numbers or you didn't try out any. Cynthia, did you pass all the numbers? I know there are some numbers which you want me to try out. Any number, or you didn't do. Those are the only options. You either didn't do, or you passed all the numbers.
I didn't do anything.
Yes, please. Let me start with one at a time.
I tried reviewing this number of log log of 27 1/9, and I couldn't get it well.
Log of 27. Where did it come from?
It was among the examples.
Log of 27. How does it read?
Log 27 1/9.
This one, eh? 1/9.
Yes.
Okay.
Yes.
Now for this one, you look at the common factor of those numbers, and their common factor is 3. So you introduce log to base 3 in both cases. From the definition of log to base A of B, when I introduce a new log to base C, I will have of B over log of C of A. Now, even this one, because you have a common factor 3, introduce log to base 3 of 1/9 divided by log to base 3 of 27. Then you simplify. This will give us log to base 3 of 1. Division calls for subtraction, minus log to base 3 of 9, or is over log to base 3 of 3 power 3. This will realize 0 minus log to base 3 over 3 power 2 over log to base 3 over 3. The 3 has gone forward. You realize that we get a negative 2 log to base 3 over 3 over 3 log to base 3 over 3. You either divide this by this and get 1, or straight away log 3 of 3 is 1, log 3 of 3 is 1. And thus the answer is negative 2 out of 3. Has it made more sense now?
Yes.
There was another lady also who had a concern. I had someone else other than you saying something. Among the numbers I sent, did you do those numbers, guys? The numbers I screenshot from the book. I'm doubtful that you tried out some of these numbers. No one sent any number on the WhatsApp group. Let me just do 1 or 2 proofs. Then I stop. Then I can go to something new. There was a proof of number 3 which said, okay, let me do these 3 proofs before I introduce something new. If log to 3 of x is p, and the log of 18 of x is q, show that log of 6 over 3 is equal to q out of p minus q. To start with, we have log 3 of x. is equal to P. You realize this is 3 power P is X. If yes, get this one and substitute it here. We shall have log of 18 of 3 power P is equal to Q. We shall realize P of log of 18 over 3 is equal to Q. I can introduce log to base 6 because the question talks about log to base 6, which will give me P log to base 6 over 3 or is over log to base 6 of 18 is equal to Q. Furthermore, this is what the question wants, so you leave it as it is, then come to the denominator. We shall have P log 6 over 3 or is over log 6 over 6 times log times 3 is equal to Q. Now, if you see that, you confirm P log of 6 over 3 or is over log of 6 over 6 plus log of 6 over 3 is equal to Q. Do you see that we shall have P log of 6 over 3 is equal to Q into 1 plus log 6 over 3. Take the log 6 over 3 with the Q on the other side, you'll have P log 6 over 3 minus Q log 6 over 3 is equal to Q. When you factorize, you are experts here now, you will get log 6 of 3 is Q, and finally log 6 of 3 is Q out of P minus Q, hashtag proof. So there are those logarithms that I gave you, which were in terms of proofs. That's why I'm wondering whether you did them. No one asked me questions about them. Should I assume you that you passed them, all of you? Guys, should I make that assumption? I know students, you don't easily make assumptions. Once they keep quiet, they either don't know what you're talking about or they didn't do and they're afraid of saying, teacher, frankly, we never tried. But it is better you say a frank bit of it and say, teacher, frankly, we didn't try out the numbers so that I can move on very fast. There's another one. It was number 3. Prove that 1 out log of base 6 of x is log 3 of x over 1 plus log 3 over 2. Hence, given that log of 3 over 2 is 0.6310, find log of 6 of 4 to 3 significant figures. So the first bit is to simplify. Because you see all of them have base 3, so they're asking you to put everything in terms of log to base 3, which will be log 3 of x, all divided by log 3 over 2 times 3. This will realize log 3 of x, all is over log of 3 over 3 plus log of 3 over 2. You realize that log to base 6 of x is actually log 3 of x, or is over 1 plus log 3 of 2. Hence proof. Now they have said, hence without using calculators, find the log to base 6 of 4. This can be the same as log to base 3 of 4 over log to base 3 of 6. This is the same as 2 log to base 3 over 2, or is over 1 Okay, all is over log to base 3 of 3 plus log to base 3 of 2. You realize that this becomes twice log to base 3 of 2, all is over 1 plus log to base 3 of 2. This will give us, because they gave us log to base 2 of 3 as this, substitute it down there, and we shall realize twice into brackets 0.6310, all is over 1 plus 0.6310. And then you can get the answer. So sometimes they can give you these questions in that form, and they say without using tables, find the value of log to base 6 of 4. So you have to find means of simplifying it until it condenses to what has been given. So they had given us log to base 3 of 2. Okay, there was number 6a. I think it's the last one I'm going to look at. Some of you may be wondering which exercise is that one. Let me screen share the exercise again so that people can see that they are not serious. They never did the number. This those of us who don't have the work, I know some of you might not even have the numbers. They are wondering, but where is teacher getting the number? So I've sent them. There is that number. There is that number what? There's that number 6a. Okay. That number 6a. It is a proof also. If you're in the group, you must have seen it. It says prove that twice log of c of a plus b is equal to twice log of c of a plus log of c, open brackets, of 1 plus 2b out of a plus b squared out of a squared, close brackets. Yeah, so they are saying prove that that is true. So with that proof, you'll see that we shall need one. We can start from the right-hand side. Because if it's a proof, you start from anywhere. So you let the right-hand side be equal to twice log of c of a plus log of c of brackets 1 plus 2b over a plus b squared over a squared, close brackets. And when I reverse this, if I take back the 2 to the a, it will give me log to base c of a squared plus log to base c. When you cross multiply these a's, you'll get a squared plus 2ab plus b squared. Okay. Now, remember, there is a denominator of what? Of a squared. This will confirm log to base c of a squared plus log to base c of the bracket a squared plus 2ab plus b squared, close brackets, minus log of c of a squared. I can vamoosh this with that by subtraction, and therefore I will get log to base c of a squared plus 2ab plus b squared. You realize that this is the same as log to base C of A plus B close bracket squared. Finally, this takes me to twice log of C of A plus B. Hashtag proof of the left-hand side. Whoever tried those numbers and they came out, you must have enjoyed them, because I know they must have been interesting a little, not so obvious to deal with, but you finally came out with the answers. Okay, let me also do number 6B. My students are still very weak. They don't want to solve numbers. They think A-level math is a joke, but they will see when papers start flying in. But let me do my role. And how come none of you has even said Happy Teacher's Day, teacher? You don't know. And yet on Teacher's Day, teacher has to relax learners, solve the numbers, they handle. You should have been the ones to solve the numbers, and I relax and I enjoy my day. But anyway, Happy Teacher's Day to me. Okay, to my students. So this is 3 log of AB is equal to 1. Now the question was saying find the values of A and B. And if you look at this carefully, this is going to be the same as what? Was this like this? Yeah. We had? Okay. If I have this, this is the same as 3. The base was what? There was no base. You have a base on the number, let me check. No, the base was A. I've written it wrongly. This is log to base A of B cubed. So this is the same as saying log to base A of B cubed is 1. You realize that A power 1 is equal to B cubed. If yes, substitute up there, we shall have log to base 3 of B cubed plus log to base 3 of B is equal to 4. We shall realize 3 log to base 3 of B plus log to base 3 of B is 4. With these numbers, we expect you to have all the laws and rules of logarithms at your fingertips. If you don't have them, you leave the number for logarithm, because you don't know when the rule will come in. So this gives me 4 log to base 3 of B is equal to 4. I can first divide off by 4, divide off by 4, confirm a 1, confirm a 1. Therefore, 3 to the power 1 is equal to B. B is 3, no wasting time. If B is 3, come back to A. A was seen as B cubed, which is 3 cubed. Our A becomes 27. Hashtag solution. I sent Understanding Pure Mathematics, UPM, by Sabila. Please go and visit that book and solve all the numbers of logarithms. I told you, in mathematics, you have no mercy, you have no option. Yeah? So what do we have? We have only one direct option, which is to solve every number we see. You must get the solution of every number you see. The reason is, if I tell you to do a few, you will not do any. If I tell you to do 5, you will not even do 1. So you have to do as many as possible. The more you do numbers, the more you become a steady, I call them steady machines in mathematics. So the more you become a steady machine. The less you do, the way you become a weak machine, an unsteady machine in mathematics, whereby if we bring a number a little twisted, you cannot handle. But if you have done all the numbers, most of the numbers, you have so many options of doing all the numbers, then you have very high chances of getting any number that comes along that line, right? Before I close logarithms, any other questions? Because I want to close logarithms and we move on to the next. I thought you'd send those numbers, but I'm the one who has even sent the numbers and I've done them myself. It means you're still lacking the morale of solving numbers, as I expect senior files to do so.
Teacher,
yes, please.
I want an example of solving the simultaneous equation.
You want one for solving simultaneous equations?
Yeah, another example.
Do you have it? Do you have the number? Do I have a number? Let me check in the seminar book here.
Yeah, teacher, they are there.
Where? Among the numbers I sent?
Yes.
Which one? You read it.
Y log 2 base 8, sorry. Y log 2 8 is equal to
2 base 8, eh?
Then, yes, is equal to x. Then 2x plus 8 power y is equal to 1. Sorry, 8192.
2 what?
2 power x plus 8 power y is equal to 8192.
Like that.
Yeah, sorry, the upper one is y log 8 base 2.
Like this, eh? Okay. And they're encouraging me. Teachers, they bring challenges for teachers to handle at least. So we have said we have y log to base 2 of 8 is x. We have said 2 power x plus 8 power y is equal to 8193. Now, do you see that from here, from this first one, you will have log of 2 of 8 power y is equal to x. Therefore, 2 power x is equal to 8y. Therefore, from here, you can either deal with 2 power x or you can deal with 2 power y. So I can start with 8 power y plus 8 power y is equal to 819. Was it 193, 192? We don't give you that.
19
what?
192, 192.
1928 is there. I hadn't seen the number. Okay. Now, do you see that these are the same? Eh? So we get 2 times 8 power y is equal to 8192. Can I first divide off the 2? Yes. I can either first divide off the 2 to give me 496. 4,900. 4,900 what? And 6.
4096.
4,096. Okay. Now we have 8 power y is equal to 4,996. I can introduce log on both sides. Log of y is equal to log of 4096. Y log of 8 is equal to log of 4096. Therefore, y is equal to log of 4096 or is over log of 8. Calculator, get me the answer.
4.
4. Exactly.
Yes.
Okay. When you see such answers, you give yourself a tick to the sky. So if y is 4, come back here. Remember, 2 power x was equal to 8 power y. But do you know that 8 power y is 2 power 3 power y from indices, confirming 2 power 3y? If that is the case, Then this power is equal to this power because these bases are the what? Are the same. Therefore, x is equal to 3y, and we confirm x is 12. If you want to confirm whether you're right, substitute here 2 power 12 plus 8 power 4. Confirm. What answer do you get? If yes, you're on the right track. If not, you rub everything and start working again. Are they true? Okay, hope that's right. Isn't it? Okay, so the rest of the logarithms, they are for the learners. Whoever doesn't solve, you'll meet them in the exam and they will show you that they are not just simple logarithms. By the way, logarithms are the concepts which have been used to build systems in computers, especially when it comes to binary and base 10. Yeah? When we have numbers, bases, base 10, base 2. Binary base is the one that builds codes. It's the one that builds code switches, because the switch has 2 codes. The first code in physics, it's called a NAND gate. The other one is called a NOT gate. This is the NOT. This is the NAND gate. Not a NAND gate. So this is yes. This is no. This is on. This is off. So everything that has on and off was designed from logarithms and from bases of binary, which is binary base 2. Whereby if you have a switch of a light, look at me here. If I switch off my light, I've applied a NOT gate. If I have switched on, I've applied a NAND gate. So code 1 in computer systems is the figure 1. Because you write binary bases in terms of 0 and 1. They are the only 2 figures under binary base. So they come from this mathematics. So figure 1 means yes, figure 0 means no. So 0 means off, yes means on. So anything you know, as long as you have on and off comes from binary bases of mathematics and logarithms. So some of you might wonder, where are these things applied? So computer systems, computer information, your phones, your laptops, your TV sets at home, your decoders, they are all using binary codes coming from this mathematics. Okay, I had forgotten to mention the application. Okay, with that, so that is why you have to make sure that you understand them very well. You never know. Some of you might do computer science and you're going to coding, or you might do advanced level physics and mathematical physics, and you learned those items. So with that knowledge, you can go ahead and introduce quadratic equations as our new topic. Let me use a new page. Quadratic equations. Someone's not muted, I think. Yeah. Okay. So here we are in a new topic, new definition. And the new topic and the new definition we are looking at is what we are calling quadratic equations. We have all seen a quadratic equation. There is what we call a quadratic expression. We have a quadratic expression. which is in the form ax squared plus bx plus c. An expression is a mathematical statement which is just written in terms of either figures and unknowns or variables without an equivalent term or without an equal sign. Whereas an equation quadratic equation, for it is expressed in terms of figures, unknowns and unknowns, but it is equivalent to something else. So whenever it is equivalent to something else, it becomes an equation, because the word equation comes from the equaling to something else. Okay, so with that reason, we see that we are having what we call quadratic equations, expressions. You saw them in O level, and of which we also expect you to be knowing how to solve them. But of course, I know when learners finish senior 4, they first throw the books away plus their brain. So we shall have to review some of the methods of solving quadratic equations. So generally, a quadratic equation is an equation in the form quadratic equation. Quadratic equation is an equation in the form ax squared plus bx plus c is equal to 0, whereby a is not equal to 0. If a becomes 0, it becomes a linear equation, not a quadratic equation. So beyond quadratic equations, we shall see what we call polynomials as we go ahead. So with that definitions, let's have methods of solving quadratic equations. So can you people confirm that you got distinctions in math? Or credit 3 the worst? Let me confirm. Cynthia, to confirm to me that you passed mathematics. Give me one method of solving quadratic equations.
Factorization method.
The factorization method, very good. Factorization method. Birundi Shakira, give me the second one.
The bulldozer method.
The bulldozer method. The bulldozer method, if I was teaching the kids of USA, they would wonder, teacher, what are you meaning by bulldozer? Bulldozer was invented by our teachers here in Uganda, but it is called the quadratic formula. Okay? The quadratic formula. So you call it bulldozer, but in actual sense, it's called the quadratic what? Formula. I don't want you to go abroad, to go to Massachusetts or to Harvard or to Oxford or to those, first class world universities. And when they ask you for the method you're using and say bulldozer, everyone will look at you. Imagine you're a class of 60 and all eyes plus the teacher land on you. Hey, bulldozer, are you talking about these tractors we have in our farms or what? So the reason why it was brought out as a bulldozer, it's because of the geography we studied in senior 2 when we used to study about the Canadian prairies, whereby they could bring machines that simplify work, which we are called bulldozers. So when the equation was brought, learners of senior 2 of that year said, hey, teacher, you mean it's like a bulldozer? And the teacher was like, okay, bulldozer, it simplifies work. Yes, okay, you call it bulldozer. I don't know which teacher invented it, but that's where it is taught. It is taught in senior 2. Even the Canadian prairies are taught in senior 2, where bulldozers are talked about a lot. So we ended up having bulldozer method. But in mathematics language, it is called the quadratic formula. Okay, can I have one more? Maria Kankwasa, give me one more method. Just a left or what? I'm only teaching girls of late. Maria. Maria, don't you recall one? Lutuleila, give me one other method.
Teacher, what is of squares?
What?
Using of squares.
Completion of squares. It's called the method of completion of squares or completing squares. So these are the three basic methods. I expect all of you. Leave alone the graphical method, that one we shall not use it. Yeah? So in A level, these are all useful topics. They are applications. Okay, they can set a number on quadratic equations because we shall see them in details. But whenever it is just about solving the method, the other one should have been a calculator. But no one teaches calculator method. We just use the calculator to confirm any answers coming from these three. So please avoid using a calculator. Always show us the method you are using to solve a quadratic equation. Okay. Examples. These are all just reviews. Solve the following. Solve the following. Quadratic equations. Using factorization method. Whereby A, we have x squared plus 2x minus 24 is equal to 0. B, 2x squared minus x minus 6 is equal to 0. I've been using some of these methods and some of you are wondering, what is teacher doing? Now we are going to go in details of seeing how these methods are dealt with. Now, for factorization method, we require the following. You investigate the product and the sum of two coefficients, whereby the product should be coming from A times C. Then the sum should be equal to a negative B. No, the sum should be equal to B. So in this sense, for example, you have x squared plus 2x minus 24 is 0. So the product will be what? The coefficient here is a silent one. It will be 1 times negative 24. So the product is negative 24. Then the sum is 2. So the question is, which are the two numbers? When you multiply it, you get negative 24. When you add it, you get positive 2. Who can give me those numbers? Marcy.
Negative 6 and 4.
Are you sure? Negative 6 and 4. When negative 6 and 4 are added, they don't give us negative, positive 2, making it wrong. Give me another one.
6 and negative 4.
6 and negative 4. This is correct. Okay? So it's okay to investigate as many times as you can so that you'll get the right thing. When you get it, when you get those figures, place them where you have the middle term. So we shall have x squared plus 6 minus 4, where the 2 6 minus 24. But because is going to be is equal to 0, because we are going to advance and become advanced mathematicians, with time we shall just need to write this straight away as x squared plus 6x minus 4x minus 24 is equal to 0. Therefore, x into x plus 6 minus 4 into x plus 6 is equal to 0. With this method, you don't need a calculator. You'll have x minus 4 bracket of x plus 6 is actually 0. Either x minus 4 is 0 or x plus 6 is 0. confirming x1 as 4 and x2 as -6 as our answers. And avoid, some people think this bracket is always the answer. No way. This is just a coincidence. Beginner's luck. Let's check out our second example. On the second example, we have 2x squared minus x minus 6 is 0. The product is what? Is 2 times -6, which is -12. The sum is what? -1. Two numbers, when you multiplied, you get -12. Added, you get -1. Who is here to give me those suggestions of those figures? Habiba Namuteri. Which two numbers could they possibly be? Namuteri Habiba, you have an emoji with shades. It is looking at me. I'm also looking at you. Habib, are you there? The factors of 12 are 1, 12, -1, okay, -12, 1, 1, -12, +12, -3, 4, -4, 3, -2, 6, 6, -6, 2. In case you don't know how to find them, it requires you to list down all those factors. Then start eliminating one by one. And say 1 and -12, when I add them, do they give me -1? No. -1 plus 12, do they give me -1? No. -3 plus 4, do they give me -1? No, they give me 1. When I add -1 and 3, does it give me -4 and 3? Does it give me -1? Yes. If yes, there is no other which can do that. You can confirm if you want to. 6 and -4. -2 when added, you get 4, not -1. No. -6 plus 2, when you add, you get -4. Obviously, no. So the answer is always one bracket, one pair. So Habiba, if you didn't know how to get them, I've showed you how to get the factors. So the pair is -4, 3. So if it is -4, 3, then this is what is going to happen. We shall have 2x squared plus 3 minus 4, x minus 6 is 0. Realizing 2x squared plus 3x minus 4x minus 6 is 0. Therefore, I can factorize here to have x into 2x plus 3 minus 2 into x plus 3 is equal to 0. Therefore, x minus 2 and 2x plus 3 is 0. This will confirm x is 2 and x is -3 out of 2. Out of? This is what I told you, that the answers may not necessarily be the factors you identified earlier there. You see that the bracket you identified is very different from the answers we have got. And then can you also confirm with the calculator? Those of us who have calculators, go to the calculator. The calculator, I told you, should just confirm the answers, not using it to get answers. You always have to show the method of the work. Okay? Do we have our calculators ready? Press mode until you reach quadratics. Are we there?
Two and -1.5.
Which is -3/2. Is there any person who does not know how to use a calculator? There was that third number. If people took a screenshot of it, it was saying negative 3 x squared plus 4x plus 2 is equal to 0. Now, before you solve the number, you can even note. Remember, I told you the quadratic equation is in the form of this. If b squared is less than 4ac, yeah, then the equation has no roots. Whereas for this number, if you look at it, when you have the product, which is negative 3 times 2, which is negative 6, and you have a sum, which is 4, there are no two numbers which, when you multiply it, you get negative 6. For example, check the factors of 6. 2 and 3. If 3 is negative, 2 can be negative and 3 is positive. When you multiply them, you get negative 6. When you add them, you don't get 4. Another one is 1 and 6, negative 1, 6, or 6, negative 1. Still, when you add them, you don't get 4. Those are the only factors of 6. So it means they are all not possible. So the equation is not factorizable. Not being factorizable does not mean it doesn't have roots. Not having roots means you can't find its real values of x. There's a topic called complex numbers. We shall see it ahead, whereby we have roots of equations which are not having real values. They're imaginary values. So if it doesn't have roots like this one, then it goes for other methods, which other methods can include the quadratic formula, as I'm going to show you. Okay. Solve the following equations using the quadratic formula. The first one is going to be that very number. The second one is going to be x squared plus 4x minus 1 is 0. The third one will be for the learners. What does the formula state? It states that the values of x1 and 2, we don't need to derive it. We have seen it in O level. Is minus b plus or minus square root of b squared minus 4ac, all divided by 2a. According to our question 1, negative 3x squared plus 4x plus 2, our a is negative 3, our b is 4, our c is 2. So the values of x1 and 2 shall become negative 4 plus or minus square root of 4 squared minus 4 times negative 3 times 2, all divided by 2 times negative 3. We shall realize the following. When you simplify, it becomes negative 4 plus or minus under the root of 4 squared minus open brackets 8 times 3, you get negative 24 all is over negative 6. We shall realize negative 4 plus or minus under the root of 16 plus 24, all is over negative 6. This will give us negative 4 plus or minus root of 40, all is over negative 6. You see that this is negative 4 plus or minus 2 root of 10, because root of 40, remember SATs, root of 40, that's why every topic is very important. We cover the topic and you misused it, it comes back to you later. Divide by negative 6. I can divide everything by 2, and I would realize negative 2 plus or minus root of 10 over negative 3. So x1 will become negative 2 plus root of 10 over negative 3. Then x2 will become negative 2 minus root of 10 over negative 3, which definitely becomes a plus. So can you get me the values? X1 is what? And X2 is given by what from the calculator?
X1 is negative 0.3874.
Then X2?
1.7208.
If you want to confirm whether you're right, just pick one of them and drop it here. And see whether you get the answer as 0. Confirm, is that the same answer?
Excuse me, teacher.
Yes, teacher.
How come x1 after dividing, how come x1 stayed negative 2 plus root 2? I thought when you divide also the negative sign also goes away.
On this first one, the numerator, what is root of 10? Root of 10 is 3 point something.
3.1623.
Minus 2. You get 1 point.
1.1623.
Divide by negative 3. The answer is 11.
1.1623.
1623. When you divide by negative 3, the answer is a negative. Because division and multiplication are commutative. Where the sign changes in multiplication, it also changes in division. Okay? So it has to remain negative. Let me do the second one. The third one is yours. Then the other method of completing squares, I'll discuss it next time. This one says x squared plus 4x minus 1 is 0. Our A is 1, our B is 4, our C is negative 1. Always identify them before you use the formula. Is equal to negative B plus or minus root of B squared minus 4AC, all is over 2A. So this will give me -4 plus or minus under the root of 16 minus 4 times 1 times -1, all divided by 2 times 1. This will give me -4 plus or minus root of 16 plus 4 divided by 2. We shall realize -4 plus or minus root of 20, all is over 2. So x1 is going to be -4 plus or minus 2 root of 5 over 2. And finally, x1 is going to be -4 minus 2 root 5 over 2. Then x2 will be -4 plus 2 root 5 over 2. Calculator, give me the answers. So this is knowledge you ideally know. We are just reviewing it for the purposes of what we are going to have coming next week, God willing. Answers?
-4.236 and 0.2361.
Negative?
-4.236 and 0.2361.
You check them by investigating, putting them back and see whether you get the same answer. Also check out the following. I will also use the other third method to do them, but you can investigate using also those methods. X squared plus 3x minus 1 is 0. 2x squared minus 6x plus 1 is 0. 3y squared minus 4y minus 2 is 0. Yeah. Then if 4, ax squared plus bx plus c is equal to 0, derive the quadratic formula. This is an assignment. You inbox me your solutions. Okay, unless if someone has a question. Otherwise, our 1 hour is over. It's done. Okay, if no questions, you can meet. Physics, today you're meeting Mr. Mukwaya. He's not around tomorrow, so I'll see how I can meet you tomorrow in his time. Have a nice day.